Number 14 is very similar to number 12, just a slightly different format. What is different here is I want this radical to be all by itself. I don't want any extra numbers. So I'm going to start by moving this dot over to the other side. Now this looks just like number 12 with different numbers. Number 12 is x plus 4 and the square root of x plus 6. Same type of format. So I want to find a way to eliminate this square root. So I can do that by simplifying here. I take the square of both sides, and then the square root and the square, we think, again, they're eliminated. In reality, they simplify to a 1. I bring down the 5 minus x. How do I know when I have to write it, in this case, twice? Because the two terms are separated by either addition or subtraction. Then I'm going to FOIL front, outside, inside, last. I'm going to move the 5 over by subtracting, opposite operation. I'm going to add the x over, opposite operation, and combine like terms. Now, what can I do to get the answer at this point? I could graph it and look for the real zeros. I could do the quadratic formula, or if it's easy, I could factor. Do I know two numbers that multiply to give you -4 and combine to give you +3? I do. +4 and -1. Leading coefficient is a 1, so I don't have to worry about bottoms up, but I'm getting an answer of -4 and +1. How do we check for extraneous solutions? One is you could do mental math, and I'm going to show you here. I plug in a -4. 5 subtract -4. 5 subtract -4. Well, two negatives would make a positive, so 5 subtract -4 is really a 9. 5 subtract -4 is really 9. The square root of 9 is 3. And 3 and a -1, +3, -1 is a 2. So 2 is on the right side. On the left side is a -4. That's why this is an extraneous solution. Checking 1. 5 minus 1 is 4. The square root of 4 is 2. +2 and a -1 is 1. And on the left-hand side, the answer is also 1. If the left equals the right, we know that's a solution. Alternatively, I could have put in x and then -1 plus the square root of 5 subtract x. It will eliminate any extraneous solutions. I think the answer is 1. It does appear they cross at 1. I can just check by going second trace, value of 1. Oops, excuse me, second trace, value of 1, and I can see they do cross there at 1.